So let's start with natural log. And we know the graph of natural log. We know the limits and so on and so forth. This is the graph. We graphed it a long time ago when we reviewed. And we would like to determine the rate of change of this function. No, we're not. I'm not going to scare you with the definition. We're just going to go directly to the formula. But I need to explain one very important topic here after we differentiate. So the derivative of natural log x is 1 over x. And of course, you know the drill so far. It's always the truth. So this is 1 over the function times the function prime. Yes, I should have written times x prime, but who cares? It's 1. Just to see for by comparison, so you do not forget that if we have the natural log of a function prime is 1 over the function times the function prime. One very important item here is, let's look at the following function. Very important. Why is this very important? You will see in chapter 5. It's very important for chapter 5. So let's take a look at a function that is natural log of the absolute value of x. Let's call it f of x, natural log of x. Natural log of the absolute value of x. So like in all the functions with absolute value, where do I start? I need to simplify this. Javon, will you tell us where to start? Javon, are you with us?
Sure.
So where do we start? What do you think? We want to simplify this function. Every function
Absolute value.
Absolutely, thank you. Good. What is the absolute value equal to? Great job.
It's x and negative x.
Very good. If
X is greater than or equal to 0.
Very good. And the other one has to be the opposite. Good. So then this function has two options. One option obviously is natural log x. However, I cannot have 0. Not in natural log. It's okay for absolute value, but not inside natural log. And the other option is the natural log of negative x for x less than 0. I would like us to determine f prime of x now for this function. So natural log of the absolute value of x prime, and we have two options. Can anyone help here? Oscar, do you want to try?
Okay, so for the first one would be 1.
So the derivative of natural log is 1 over x.
Oh, 1 divided by x.
1 divided by x for x greater than 0. And who would like to do the other one? Mickey, would you like to try the other one?
It would be negative 1 over x for x is less than 0.
Okay. So if we have anything else but x, which is not x, negative x is a function now. I have to have 1 over the function times the function prime.
Is it going to be 1 over f of x?
Which is? Just to make sure we are looking. We must be looking here. We cannot invent anything. We are looking at this. To determine the other branch. The derivative of the...
negative x?
Say it again.
Is it 1 over negative x?
Good. Times the inner function prime.
Is it 1?
Times negative 1.
Times negative 1. Very good, for x less than 0. Okay, now I want to fully simplify this. So this is 1 over x when x is greater than 0. And what is the other piece?
1 over x for x is less than 0.
For x less than 0. So they are the same. So then the answer is not two different branches, it's just one. For x between negative infinity and 0, union 0 to infinity. And this is a major result for chapter 5. And please remember, I'm going to write here our conclusion after discussing the natural log of absolute value. So, natural log of the absolute value of x prime is 1 over x. Why is this so important? I'm going to write it here. Do not write it as not right for right now. We will get to integrate 1 over x dx. And the answer cannot be natural log x plus a constant c. Because of this, it must be the absolute value, natural log of the absolute value of x plus a constant c. So that's why this is a major, very important result. Not for now. This is for chapter 5, later on. Okay, so I'd like to practice a few. Let's say f of x equals sine x times natural log 5x. Can anyone get us started with this? We want to find f prime, of course. We are just practicing what we just learned. Anyone would like to give it a shot?
Is it cos x
Very good. Times natural log 5x. Very good. Plus
plus sine x
sine x times
is 1 over 5x,
multiply times by the inner function prime.
then 5.
That's it. Great job. Thank you very much. This will go away. So then the final answer, I cannot do anything else, but just rewrite it. Cosine x times natural log 5x plus sine x over x. Done. Okay. Let's look at another. Let's say y equals natural log of e to negative x plus x e to negative x. Because this happened at the beginning. Can everyone see this? Is it clear enough for everyone?
Yes, it's good.
Okay, sorry about that. I don't know why that glitch happened at the beginning. Okay, so can anyone give us a starting point here?
Factor out the e to the negative x.
It will not help. Very good. Actually, thank you. Thank you, thank you. So we factor, simplify, anytime except, so almost all the time, except inside functions. It's a very good point. See, if you hadn't said that, I would have not mentioned this. I would have never thought of mentioning it. So thank you. So this is natural log, this is the outer. This whole thing is the inner. Even if I factor something here, I will have an outer of a product, which complicates things. So I will not be able to simplify to make my life easier. Very good point you are making. Thank you. Okay? So in this particular case, that will not help. It's inside a function. In other words, it's the inner function inside of an outer. Okay. So perfect. Thank you for saying that. So who can get us started on this? Who I have? Trey, I haven't heard from you, please.
Be 1 over degrees.
Yes, of course. Yes, it is. That's the starting point. 1 over e to negative x plus x e to negative x times
The inner.
okay, I'm ready.
Is it the derivative or just the e to the negative x?
But wait. A natural log of a function prime is 1 over the function times the inner function prime.
So it's going to be e to the negative x plus
Times the inner function prime.
-1.
Say it again.
-1.
Very good. Remember, don't get into that trap. E to the x prime is e to the x, but e to negative x prime is not e to the x. Very good. Now plus. Anyone?
x
Prime is 1. E to negative x plus x times
-1.
e to negative x times -1. Everyone okay with this? Yes?
Yes.
Okay. Now, because e to negative x is not inside a function anymore, I will do what 10 said. He knows I love simplifying and factoring. So that's why he said that. So e to negative x comes out from the denominator. Leave the numerator for a moment. Leave it alone. Tell me what is left in the denominator.
1 plus x.
That's it. So now I see 3 terms. 1, 2, 3. They all have what in common?
E to the negative x.
E to the negative x.
Good. Can anyone tell us slowly what we have to write? I have 3 terms. I have to write 3 terms.
Would it be negative?
Negative.
Right?
Yeah, -1 plus 1.
Right. I should have simplified these, but that's okay. Which is going to be 0 anyway. And minus
Plus.
minus x. Great job. These two go away. So in the simplified form, the top is negative x. The denominator is x plus 1. Quite neat. Very good. Any questions? I love it when everyone contributes. I don't have to call on anybody, and that's awesome. Okay. Let me refresh your memory on something from our recent past experience. We said again that e to the x prime is the nicest of all. We also said that e to a function prime is what again? Anyone?
E to the f times the function of f
Prime.
prime.
Okay. What about a to x prime? What did we say about this? Jordan? Not Jordan. I haven't heard you today.
Would it be a to the x times natural log of a?
Great job. The same thing for a to a function prime. What do we get then?
A to the function times natural log of a times the function prime.
Also awesome. Okay, now we know that the natural log x prime is 1 over x. We know that natural log of a function prime is 1 over the function times the function prime. This is very similar to, it's not the same function, but it should remind you of this. Close. Okay. I have to add one more function here, which is log base A of x. And of course, log base A of a function prime. So notice what the difference here is, that this one has any base, not e, not natural log. So in this case, we have 1 over x natural log A. Same thing here, 1 over f natural log A, and of course, times f prime. And now I would like to practice this, and then we'll look at logarithmic differentiation.